physics students. I'm going to show you how to use trigonometry to solve a basic physics problem. A man walks 6 blocks north and then 2 blocks east. What is the man's displacement? We are going to usually, unless otherwise specified, describe north as being up and east being to the right, west to the left, south down. So the first thing we're going to do is we're going to draw this picture of what this man's motion is here. So the first thing we're going to do is draw a little picture. He's going 6 blocks north, 2 blocks east. And the displacement is the distance and direction from where he started. So that would be this line here. Now, you're very clever, and I know you've probably noticed that this is a right triangle. And you've learned a lot about ways to solve right triangles, and trigonometry is another one of those things that you can do with right triangles. So we are going to first use good old Pythagorean Theorem to find the magnitude of the displacement. And Pythagorean Theorem is a squared plus b squared equals c squared. Right? So we've got 2 squared plus 6 squared equals c squared. And that's going to be 4 plus 36. So that's 40 altogether. But I don't want it squared, I just want c. So I'm going to take the square root of 40 to find the magnitude of the displacement. Magnitude is just the amount, the number. So let's get out our calculator here and take a look and see what is the square root of 40. You'll see that it's 6.32 and then a bunch of decimal places. Now if we look at our question, you'll see that we have 2 significant figures in each part of our problem, which means we can only have 2 significant figures. So we can round this to 6.3. So 6.3 blocks is the magnitude. But what about the direction? This is where the trigonometry comes in. The direction we're going to be looking at is going to be called theta. That's what this little angle is here. And we're going to describe it as how far east is he from north. Okay? So kind of like a compass heading. Which way should he go? And we're going to write it in terms of degrees. And we're going to find the number of degrees in that angle using our trigonometric ratios. Now let's look at those again. They were on my website. We saw that sine is the opposite over the hypotenuse. Cosine was the adjacent over the hypotenuse. And tangent was the opposite over the adjacent. SOHCAHTOA, that's a way to remember those. Now in our problem, we are given which particular sides. The opposite is going to be the side that's opposite our angle theta. So 2 is our opposite side. 6 is our adjacent side because it actually makes up part of angle theta and it's not the hypotenuse. Hypotenuse is the longest side in a right triangle. So we're going to use what's given to us instead of what we calculated. So you'll see that the only one that we can use for that is going to be tangent. So what we're saying here, our little trigonometric sentence here, is the tangent of theta. Now the tangent is that ratio of sides, is equal to 2 over 6. And if we go ahead and calculate that out, that's 1/3 or 0.333333333 forever and ever and ever. Now that's not the number of degrees in our angle. That's just what you get when you divide the 2 and the 6. But those clever Greeks, and actually the Egyptians before them, found out that certain right triangles have certain ratios to those sides, and they'll always tell you that particular number of degrees in the angle. And we used to have to look these up in tables when I was in school. Yes, I'm that old, but you do not have to do this. You have a calculator that has it programmed into your calculator, and so I'm going to show you how to do that. What we're going to do here is we don't want the tangent of theta, we want just theta. So what we're really doing technically is we're dividing that 0.333 by the tangent. Okay, we're going to do that. Don't worry too much about that. We're going to be using something called the inverse tangent or the arc tangent. I'm going to show you how to put that in the calculator. All right, on your calculator, you will see that you have sine, cosine, and tangent. Every calculator is going to look a little bit different, but you should be able to do the inverse. And that's what we see in blue above these keys. So it's sine and then it has a -1 exponent. Anytime you see -1 exponent, remember when we did scientific notation, that means we're dividing by that. Okay, so we're going to use this second tangent, and that's going to give us the inverse tangent. And what we're going to do is we're going to put in 0.3333, and we're going to hit enter, and it gives me 18.4. That's the number of degrees that are in that angle theta. So what I can say is my guy here, he walked 6.3 blocks, 18 degrees east of north. Okay? Now, I'm going to show you one other thing before we end this. I got the correct answer because I had already preset my calculator to degrees. You are going to need to check and make sure that your calculator is set to degrees and not to radians. If you have a TI calculator like this, you're going to do that by clicking Mode. And then you'll see here that you've got radians and degrees. You'll go down to where it says radians and degrees, click degrees, and hit enter. If you get some kind of odd number, like a decimal number for your degrees, you'll know that you have this set wrong. Hope this helps. As always, contact me if you have any trouble with these. I will be more than happy to help you. Have a great day. Bye.